This is a quick summary of what we're doing when we are learning how to navigate from mass to moles, or from volume to moles, or from the number of particles that we have to moles. The number of particles are going to be either formula units if we're talking about an ionic compound, or molecules if we're talking about a covalently bonded compound or a member of the diatomic 7, or the other representative particle is the atom for the other elements, excluding the diatomic 7. If we are calculating, for instance, the number of particles that we have in a mole, and you are given a certain number of particles, for instance, if somebody told you that you had 3.0 times 10 to the 19th atoms of a particular substance, and you wanted to know how many moles that was, then the number of atoms that you have is the unit that you want to move away from, and you're trying to find the number of moles that you have of that particular substance. And as we can see on our mole maps, the connection between the number of particles that you have and the number of moles that you have is that for every 1 mole, you have 6.022 times 10 to the 23rd atoms. And so if we take 3.0 times 10 to the 19th and we multiply that by 1, which we may choose to ignore if we wish since it's multiplying by 1, and we divide by 6.022 times 10 to the 23rd, then that is going to tell us how many moles we have in 6.022 times 10 to the 23rd atom. And if we enter that into our calculator, we find that 3.0 times 10 to the 19th divided by 6.022 times 10 to the 23rd is 4.98 times 10 to the minus 5, and that's moles. So we have a very small fraction of a mole, which we would expect because we have a very small fraction of 6.022 times 10 to the 23rd. We have a value that is times 10 to the 19th. And so we're talking something on the order of 10,000 times smaller than a full mole, which is what we end up getting in the 4.98 times 10 to the minus 5.